Hi everyone, and welcome. It's great to see so many people here. Let's see if we can get my slides on. Just a second. Oh, hi. As you just were heard, my name is Kenneth Christiansen. I'm Danish. We used to be the most happy people in the world, so let's try to live up to that. I work for a company called Intel. You might have heard about them if you're in this industry. We do like processors, data centers, all kind of things. And we're also involved in developing the web and working on IoT. So in my day-to-day job, I work on improving the web for you developers and users. So I work on Chrome. You notice the Chrome logo. I also work on standardization in the W3C, the World Wide Web Consortium. And we also work on, of course, JavaScript. I am also a Google developer expert in web technology, so this is a super awesome program. So if you're really involved with either Android, web technology, it's possible, if you do really well in the community, that you become a Google developer expert and get like really good contact with all the Googlers. So, but we're here today to talk about smart devices. So the first question we might ask ourselves is, what are smart devices? What makes a device smart? Is this thing here smart? It could be, but if I have to like pull up my phone, unlock my phone, find that app, where is it? Okay, I'm waiting for the app to launch. Okay, now I can turn off my light. Maybe that was smarter before, where you just went and clicked on a button on your wall. It could be smart, like if you could just talk to it and say, hey, turn or dim my light by 20% in the living room. Well, suddenly it becomes more exciting. It's all about the experiences. You need to solve a real issue. And you need to be there when you need it. It's not like this, I need to find this app and figure out where it is. Did I even install it? No, it needs to be easy to find things, like just talk to your device or have a button on the wall, something simple. This is also what I call low friction. You don't want to confuse, you don't want your user to be like this. You want the user to be happy. And people are getting really tired about downloading this app. You just want to do stuff, and you want to do it now, right now. And if you think about a future where people are talking about this like era of smart devices or ambient computing, where you might have different devices around you, you might have 100 devices around you. Well, you're not going to have 100 apps installed on your phone. It's going to be really, really difficult finding that app you need at that point. So this kind of doesn't scale. It's kind of like Windows in the old days, like, where was that file again? If this was working. Oh, it's kind of getting the same way on phones, like you have multiple pages of applications. There are just too many icons. You lack the overview, and then you get these annoying updates in the background, like updating these apps that you haven't used in half a year, and you don't know why, because you probably won't use it for the next half year either. When we think about IoT, they're kind of like different use cases. There's some apps or some experiences you use like every day. It could be like to turn on and turn off the light. There's some experiences you use occasionally, like, it's getting really warm outside, I really want cold beer, so let me change the temperature of my fridge. And there are these apps or experiences you use like once per year, maybe once every 10 years, like I'm flying to San Francisco, I want to pay for my car. Like, I'll probably not use that app or that experiences again. Maybe first next year when I go back. So maybe there's a better model than installing apps for all of these things. And this is where the web comes in. We want the low friction of the web, and we want ease of use. Everyone gets this experience. Like, type in a URL, you go to the website, it's there. Then when you don't care about it any longer, you just visit another website, and it kind of fades away in the background. It's ephemeral. Well, it might be in your cache, but like then when you download or go to some other sites, it kind of slowly disappears. So it's not there, it's out of the way. If you need it again, just type in the URL. But for the web to really make it in this era and in this space, we need things to be fast. So the last couple of years, we've really been focusing, I said like before I work on Chrome, we've been really focusing on improving the web and making it work offline. So there's a lot of things going on. Something called HTTP2 push, where you can push different files at the same time. We have something called service worker, which allows you to make a site work offline or in offline cases. And we have something called a purple pattern, which is a way that you can render things pretty quickly to your screen. So service worker kind of works the way that it's kind of like a server or like a proxy server, which sits between your website and the internet. So if you're kind of like online, you can like, the site will talk to the service worker, would then like talk to what's online and maybe download an image and show it to the user. But if you're offline, suddenly you can say things like, oh, maybe I should show like a different screen. Maybe I already cached that file. So you can build these nice experiences. So you get rid of the very annoying dinosaur. The purple pattern, it's about showing things on screen as fast as possible. So now that we have the service worker, this is kind of possible. So the old way of doing things is just like you go to a site, everyone just downloads things, they don't even resize the images, they don't care about your data plan, and it just takes a while. Sometimes maybe even 13 seconds on a cell phone to just see a website. And we really want to get this down to like 1 second. So the idea here is that you just take your critical resources, the things that you'll see on your screen immediately. Nothing else, like remove the images, whatnot. Just show that like critical content, and you push that to the user immediately. Then you show it, you render it. Then in the background, you try to look at like what's else going on in the app. Maybe I have like a tab bar. So if users click there, I need to show something else. So I can go and download these things like slowly in the background, while the user already has something to look at. And then I'll just lazy load it and show it. So there's a link at the bottom. I'll share the slides later, where you can read a lot about these things. So the main takeaway here is that the web today is actually capable of delivering like native-like experiences on mobile, which are super fast and quick. So they work offline, they're fast, and they work with touch. So here's an example of the Polymer News app. You see how fast it launches. There you go. There's an app. That's just the web, nothing else. And a lot of people ask, but this is not the web, is it? Like I don't see any like toolbar. Where's the address field? It just launched from an icon. It was on the home screen. This is what we call progressive web apps. So I've been involved with this myself. So during the last couple of years, we worked on Service Worker, worked on something called the Web App Manifest, which allow you to create apps that works like native. The Web App Manifest allows you to set like how it should launch the app, like don't show the address bar, show a standalone or full screen. You can even set the orientation. You can define the icons, so people can add things to the home screen. And that's pretty useful, because we talked about these 3 cases. There's some app you use every day. So if that is the app for turning on my light bulb, I might want that on my home screen. If it's the app I just use once a year, maybe not. And the idea is you visit the site, and slowly, progressively, the more you get engaged with the app, the more power it gets, like being added to the home screen, making it work offline, getting access to other hardware capabilities. So this is really great for like these one-time use cases. And by having the icon on your home screen is always handy. Which means that it doesn't clutter up your screen with all these kind of apps you don't need. So that's pretty nice. And the cool thing about the web is that it's safe. It was developed for documents, and it's slowly been gaining more and more powers. So people don't worry about like going around the web, maybe downloading things, but like you can just visit a website, and you don't need to think about, is this safe? But if you download an app, it's like, okay, suddenly it wants to read my contacts. Do I want that? It wants to be allowed to send SMSs. Ooh, maybe scary. Maybe it's going to like charge me money for that. So the web is safe, and we've been trying to make that possible. But how does that work together with talking about IoT and smart devices? Because these are like physical devices. How do you connect to them? And how do you make that safe? Because they live outside of the sandbox of the web. Well, the web can do that too. But I just wanted to make a statement. Keep in mind, I'm going to talk about two technologies here, Bluetooth and Web USB. And keep in mind that users and companies, they don't care which technology you use. Just use the technology which makes the most sense for you. Bluetooth and USB, that's a USB logo. So let's look at Bluetooth. Why would people use Bluetooth? Well, Bluetooth is widely used. It's very easy to get chipsets that work with Bluetooth. Since Bluetooth 4, there's a new standard called Bluetooth Smart or Bluetooth Low Energy. So it means it doesn't drain your battery, which is especially nice if your device is running on a battery. And it works without a wire. It's easy to use. It's also pretty cheap. And it comes with something called beacon technology. And this, I think, is really, really powerful. It means that the device itself can broadcast something. So, for instance, it could broadcast like a URL to your web app. Disadvantages, well, you might, if you have like important things you're sending over Bluetooth, you might want to encrypt it because it's a wireless standard, so people could like figure out what's in the air. It's not powered. It can be an advantage and a disadvantage. And of course, because it's wireless, the stability and speed. So let's just look at a demo here, like someone doing a web Bluetooth app. It just shows up in a dialog. You connect to the device. I think this is the device in the middle. And here they just allow to set like the different colors. And that's just a web app, like no install was needed. And I think that's pretty powerful. So this is using a standard called Web Bluetooth. It's a quite new standard. It only works in Chrome currently. It works pretty well on Android. It's already shipping, so you can play around with it today. It might be supported by other browsers like the Samsung browser, which is also based on Chrome, but I expect this to be more widely accessible in the future. So it's based on Bluetooth 4, so this is the low energy part of Bluetooth. It uses all the latest JavaScript standard features, like using promises, which is for async APIs. It's also using typed arrays, so you send data using typed arrays. But it only works with like the newer devices, like Bluetooth 4 and up. So here's just a page that's looking at the implementation status. So it works pretty well on Mac. It works pretty well on Android and Chrome OS. Windows is still work in progress. I believe that Microsoft still need to add some enablers to Windows 10. One of the things when you're using these new APIs, we were talking about the sandbox before. There's a requirement that you use HTTPS, so this is like secure connections. This is a requirement. But you also don't want to like browse around the web and suddenly you go to a website and suddenly it's connecting to your microwave. So the thing is that it will need to show like a pop-up dialog or like a drop-down, and it needs to be instantiated from a user gesture. You need to click on something. So it's not just going to connect automatically, which is like really good for us users. So let's look at how this could look. So here's an app. The user just taps in the middle and it will pop up the dialog. So this is, for instance, for a heart rate monitor. Pretty cool. Very simple. So you know what's going on. You can just reject it. So let's look at like how this works in JavaScript, because this is the web, and the language of the web is JavaScript. It's very common API. You do like navigate a Bluetooth request device. There's some filters where you can do something like there's some standards in JavaScript like for battery service, heart rate monitor. If the device supports these, you can request that. Then if you get a device, you can do something, or you can like catch errors. So this is like the promise API. This doesn't happen immediately. It might take maybe a few milliseconds or a second depending on the device. There's also other ways, like you can request even like a UID instead, depending on how Bluetooth works. If you do your own devices, you can also just do a name. So I could do like a robot and call it like Kenneth Robot. But as this is, I will come back to that later, it's using like Bluetooth Low Energy, so it's using some standards for how you access things. And you have services. But you might have one device which has like service A and B, and another device which only has service A. So if you only like look for like the first service, then you'll only be able to access service A, even if the device has service B attached. The only way to work around that is to have optional services. So this means that if it's available, I will be able to connect to it. So this is how Bluetooth Low Energy works. You have a profile, which consists of various services, which each have characteristics. If you come from JavaScript, you can think of this like a service being an object and characteristics being like variables. So this could be like a string or a Boolean or a number. But as this is Bluetooth, a lot of people, they tend to they want to compact things. Like you're sending things over a wireless protocol, you want it to be as compact as possible. So people often would use something like an array or typed array to actually pack data, like in binary format. So maybe a characteristic could actually contain like readings from a gyroscope and a accelerometer and other things at the same time. So I'm just saying that so you keep in mind if connecting to existing Bluetooth devices. So how do you connect to a device? Let's continue. I'm filtering for my battery service. If I get a device, I need to connect to this GATT protocol. So this is also called the GATT protocol. It stands for generic attributes. When I do that, it returns me a server. Then I can do things or error. So let's look at what I can do. So from the server, I can get like a service. And now I can request the characteristics. So these are the variables I was talking about before, like battery level. If that succeeds, I get the characteristic, and I can here like read value, like what is the value of the battery. And I can print it out. Like here I know it comes as an unsigned integer in 8-bit. That's just how that's packed by this device and the standard. I can do the same thing with writing. So now I'm just getting characteristic from a heart rate control point. I'm getting that. And I'm actually I'm creating a typed array, and I'm writing a value. Very simple. But normally you want more than just reading and writing a value. You kind of want to get like subscribed to changes. And that is also possible. So I'm doing the same. Here I'm looking at heart rate. It kind of changes all the time. So when I get the characteristic, I start notifications, and I set up an event handler. Every time the heart rate changes, I would get this event would be called. So I'm getting out the value, and I'm printing it. Very, very simple and very powerful. It might look a bit complicated at first, but if you start playing around with this, it's actually really, really easy to use. But we were talking about this beacon functionality before. And Google was thinking like, this is pretty cool. Wouldn't it be cool if a device could like broadcast its own app, its own like web URL? So they worked on something called Eddystone. So Eddystone kind of is that idea. Every device, or just a beacon, can broadcast a URL. This might be pretty cool, like even with forgetting about web Bluetooth. Like you might have this device like on a poster, you're looking at a movie theater, oh, there's a new Star Wars movie, I want to see the trailer. And it'll you just put up your phone, it's broadcasting, so oh, Star Wars trailer. I click on it, opens up the web app and shows the trailer. So that is actually possible on Android today with Android Nearby and Eddystone. This is also in deployment in London. By something called, I think it's called Proxama. So you're standing next to the bus stop, you take out your phone, it will show there are some links nearby, the UI changed a bit, it looks nicer now. You click on it, and you get the web app like, oh, this is your bus, it's coming in 5 minutes. And that's kind of like the functionality. You might not want an app for that on your phone because maybe you only take the bus occasionally, but it's super nice. Instead of you having to find a QA code or type in URL, it's just right there on your device. This also works on iOS if you install Chrome and enable it. So here's another example. You could use it for like paying for a parking meter, etc. So I'm putting up a link here. As I said before, I'll share the slides later. where there's a nice articles about Web Bluetooth and how to get started. So let's look at Web USB instead. Well, Web USB, like Bluetooth, is super widely used. It's also very, very cheap, and it's cabled. So that might be useful sometimes when you want something with a really secure connection, like a physical connection, or it needs to have like stable, maybe needs to send a lot of data at the same time. It might be medical equipment. And it can also actually power devices. You can say that the disadvantage could also be that it's cable depending on your use case. It's safe. USB doesn't have any radio interference because it's a cable. And the cool thing is that you can think about if you're going to make like this web app, maybe for controlling your machinery. Maybe you have a factory, so you have like really big and powerful machinery. You don't really want people to be able to hack over Bluetooth from the outside. So you really want people to have like a physical connection. So you can even make a small latch with a physical key that you have to open up to connect to. And still you can use the web with all the advantages that it continues existing, and the app will probably work forever. And recall, as I said before, like choose your technology depending on your use case. Like if you're in a hospital, you might not want Bluetooth because it might interfere with other machinery. Maybe you want something that works when you're out and around, and you don't want to have a cable with your phone. You just want to connect to it. So maybe use Bluetooth. These technologies, they work together really well. And I want to show you one example here. This is one example of what I did with Web Bluetooth. Let's just play. See if it starts. There we go. Oh, just a second. So this example here is a small device I did. So there's a IoT board. It's actually the Arduino 101. I connected a few things to it. I have a temperature sensor and an LED. I plug it in, USB. I just did. It's turning on. You get like a nice dialog that the device is found. If I click on it, it's going to load a URL. Now the cool thing I did here is I can actually program this device in JavaScript. So I made a small like IDE in my browser. See, it already has the Web USB permission. I can press this like the JavaScript code. I press run, and it should start showing the temperature of my temperature sensor. So I pressed run. No, and there you see. Suddenly I get the temperature. That's all using like Web USB. I'm just using it as a way of programming. Just to show this actually live, I'll choose another example. RGB.js. I'll start changing the color of the LED. So I think like this Web USB is like super cool, and especially like with JavaScript, even like doing like IoT is super nice because like it's so rapid. Like you can just do changes and deploy. You don't need like to install this big tool chain of like C code and compiling a kernel and getting USB to work, installing it, getting on device, rebooting. It's like really cumbersome and difficult to get started. And this is kind of like much better. So the example showed like a smart device capable of running JavaScript. It showed bootstrapping. Like I talked about before with the Bluetooth devices could have this Eddystone, also called physical web, where it's broadcasting URL. Here you can get like a dialog as well. It can also kind of like device can also broadcast the URL. And the device here is powered over USB. So USB it's much more powerful in some ways than Bluetooth. It's also more complicated. One of the things you need to understand is there's 3 different ways of sending data. There's bulk, interrupt, and isochronous. I don't know who came up with that name. Bulk transfers are the fastest. It's about like getting things in a bulk and sending it. But if you're doing that, you're like combining data. It doesn't have guaranteed timing. So if you want like to have a keyboard, you actually want to type and see things on the screen while you type, and not like a second after. This is not the best. This is normally used by serial connections and printers. So interrupt it's not the fastest, but it has maximum latency. So this is what you want to use for your mouse, your keyboard, etc. And isochronous is more like a broadcasting, like best effort. You just stuff data, and if the device can keep up with it, cool. If not, well, doesn't matter. You could think of it like something like a web camera. This would probably be the right protocol, the right transfer type to use. Web USB, in the beginning, there were some special requirements. They have since been removed, so you can basically connect to any USB device. It will also show up a dialog. You also need a user gesture. So, but in order to create like further security and to get like that dialog, like the bootstrapping, you can add some specific web USB headers. These are optional, but they're pretty nice. You can also say, like, if you make a device, like, okay, this is the only site which can access this device. I don't want anyone else to do that. So you can kind of whitelist sites. And this is the dialog I'm talking about. Maybe you're really excited now and want to go home and play with this, so I just wanted to point out that there's a few issues with USB in general, especially platform support. A lot of people, they like using serial connection because it's easy. It's like send data, receive data. It's really, really nice. But on Linux, there's something called a modem manager, which really hijacks USB devices. Like, I spend a lot of time waiting because it hijacks for like 16 seconds. It just like takes your device and says, yeah, no one else can use it. There's a way to get around that by actually fixing modem manager and getting your device kind of whitelisted. But getting that into distribution like Ubuntu can take up to 2 years. But if you work on Chrome OS, just send the patch to Google through like the Chromium bug tracker, and they'll integrate it as quickly as possible. They really want these things to work for you. On Windows, there's also a lot of different problems, and the basic takeaway is that it works on Windows 10. On older version, it's really, really difficult. So just as we did with Web Bluetooth, let's have a look at how you connect to these devices. I'm using promises. You see all the .den, and catch. But JavaScript is improving, and now we have something called async await. It's basically in most browsers today, like the newest version. So this could look much easier. So this is basically the same code. This will wait until this is fulfilled, and then it will continue executing. So what I'm doing is I'm requesting a device. There's also a filter. I set here vendor ID for my device. Then I open it. This is how USB works. I need to select the configuration. Then I need to claim one of the interfaces. Then I can send data. I was talking about 3 different transfer types before. I forgot to mention the fourth. The fourth is the control data, like what you want to do. So I'm just sending some data here. I can also receive, as USB is like a client, like a master slave kind of way. The computer is, or your phone will be the master. Your peripheral, your device will be the slave. You also decide to get data. You say, like, give me this data. Here I'm getting some data. I'm getting a text decoder, and I'm printing the result. Also quite easy to use. This works in Chrome today on Linux, Macs, and on Windows, with a few quirks on Windows, but it's getting better. And as before, there's a very nice URL where you can check out all the information about Web USB and how to use that. Wow, there was a lot of information about Web USB and Web Bluetooth. But that's not the only thing going on the web. We've really been focusing the last years on making the web a really capable platform for developers and users. So we just came to this conclusion that the web is really good for these one-time interactions. So it's actually a lot of companies, they tend to track things. It's like you have a stock, you sell products. So it's very common that you do some kind of tracking. A lot of people, they use like QR codes, they use barcodes, etc. And the web is really good for interacting with devices around you. So can we combine these things? Well, in some situations, using Bluetooth beacons might be the best solution. But for instance, think about like you're mailing out like small packages. Having a beacon for every package might be a bit costly. So there might be other solutions. It could even be NFC tags. But the QR codes and barcodes are pretty powerful and pretty widely used. And they're also very cheap. You can basically just print them. So we're working on new APIs in Chrome. And I'm pointing out that this is behind a flag, so this doesn't work out of the box. This is something you can turn on, which will become part of Chrome in the near future. Here I'm creating a barcode detector. Then I can just give it an image, or I could give it a camera stream. And from that, it will detect barcodes. I can then read the barcode and do something with it. This is actually part of a new API called the shape detection. So this is not just for barcodes or QR code. It actually works on like recognizing people inside a picture. And all these things that will be supported by cameras and smartphones. Very, very exciting development. NFC is also pretty useful. Sometimes you actually want to like exchange data, or maybe you want to have like an NFC reader when students are coming in, they'll tap their phone to be registered. And we've been working on an API for that as well. This is also behind the flag in Chrome. And this is actually becoming what we call an origin trial in Chrome. So I don't know if you've heard about origin trial. So we kind of realized that developers might want to turn off a flag and use it in Chrome, and they can make all these nice demos and show to people. But big companies, they want more. They want to get like, it's really hard to tell the people like, hey, you need to go into this weird settings, write about .flags, and then you find this setting, search for it, and then click and turn it on. Like, maybe there's a better way. So the way we came up with this is that while an API, a new feature, is not fully baked yet, we enable it as an origin trial. This means that if you're excited about this new feature as a user or as a company, you can apply for a token. So you go to a specific website, you say like, I want to use NFC. They'll give you a token and say like, okay, for the next Chrome release, this is your token. You put this token either inside your HTTP headers or just as a meta tag in your HTML. And suddenly the feature will work for all users of Chrome for that release. The reason why you don't get a token that works forever is that there might be changes. So maybe we figured out that that was a really bad idea and we need to change the API a bit. So next time there's a Chrome release, you will test with the beta before, the beta release. You make sure that everything works. You're ready to roll out your new release, and then you can request another token. Normally, this might run for a couple of Chrome releases, depending on how stable the feature is. And the idea is that after that, it will go to become a stable feature and ship in Chrome. This is exactly what happened with Web Bluetooth. So let's look at NFC. This is also a very, very easy API. I would like to think so, as I've been working on it myself. So if not, you can complain to me. The idea is that you can push, like, I don't know if you know how NFC works. In NFC, you talk about two different device types. You talk about passive devices and active devices. So your phone, it has power, it's called active. And an NFC tag will not, usually be passive because it doesn't have any power. So the way it works is that when I bring my phone close to the tag, my phone will actually send out currents, which will power up the device. And when that happens, they will exchange data. So they will like read or write, or do both. So what I'm doing here is I'm writing code that will allow me to push a message to my tag when my phone touches it. So here I'm just writing URL. Very simple. Here's much more powerful. I would actually, at that same time, I will try to read or figure out whether it's empty. If it's empty, I will write some JSON. This is really easy because JSON is like the very, very used in JavaScript. So I just write like first name, Kenneth. If it's not empty, I go to the else clause, which call this process message. Here I go through I can write like different records. I find the JSON one, and I just print out hello, whatever's there, like hello Kenneth. If there was an image, I could do that as well. I can even like get a blob of the data and actually show it on the screen. So this is also a very powerful and very easy to use API. And even like I was demonstrating this to Tim Berners-Lee, the inventor of the web, and he even thought it was pretty exciting. So I love that picture. So we've been talking about connecting to other devices to like either control things or to get input, like tell me the temperature or set the color of a light. But what about things already on my device? Like I have a nice phone. It has like an accelerometer, a gyroscope, a magnetometer. It even has a temperature sensor for the battery. So why can't I just access that? Because I might not need this other IoT device, because I have everything I need in my pocket. So we've been looking at sensors. So how can we connect to these? Well, we wanted an API which worked really well for the web, for your phone, for your laptop, but also when working with remote devices, so you don't need to redo your code all the time. And it has taken a while, because it's actually really, really difficult coming up with a very nice solution which is generic enough that it works in all these use cases, secure, because like people, they always find out how to abuse things, and easy to use. So we've been working on this called the Generic Sensor API. It's a big document detailing how to create generic sensors. And on top of that, we've made like smaller specs for specific sensors like gyroscope, magnetometer, accelerometer, ambient light sensor, and actually many more. Even now we've been working on orientation sensor, which is super exciting because, like, I don't know if you've seen the news, but a lot of people talk about VR, especially web VR. And these sensors, they have like gyroscope and whatnot inside. So we really want to use the same APIs. So we also work on orientation sensor. But one thing, like I've been working on this myself, so I'm actually one of the co-editors of the orientation spec and some of the other specs as well. And one of the things I thought really, really difficult is that you cannot buy a good book telling you how to deal with different sensors. I just couldn't find one. Then there are a few like good YouTube videos, but like it's really, really tough. It's like people, they don't know. Like a lot of the info you find online is actually plain out wrong, and it just looked like people, they just tried their best because there was no good resources. So I actually took all my knowledge and I wrote an explainer for motion sensors. So if you really want to deal with sensors, know what is sensor fusion, what is a low-pass filter, high-pass filter, when do you use one, when do you use the other, what's a gravity sensor, linear acceleration sensor, go check out this motion sensor spec. It should provide a really nice overview. But let's look at the API. As I said, we wanted to make it really, really simple. I'm making a new accelerometer. You can pass in a JSON, like some JSON, or it's actually just a JavaScript object literal. Here I'm setting the frequency, and that's it. Then I get my device. Then I can subscribe to unchanged events and do things. It will only start when I actually type start. Very simple. I'm not doing anything here though. So let's try to do something. One of the canonical examples is to do what's called a complementary filter. So I don't know if you've ever seen sensors, but like your phone will have a gyroscope. It's kind of like figure out like how you're holding it. But it has the problem that it's tilting over time. It doesn't know what's down and what's up. So it might look really nice in the beginning and suddenly it will start moving slowly. It'll be wrong. Because there's noise interference in your device. There's all kinds of other things like affecting it. And it will slowly build up over time. It also has an accelerometer, which like senses linear acceleration, so like how you're moving it. There you really want like a lot of events all the time. it's kind of like the obvious, like instead when you're shaking it, it's not responsive. So it's kind of the opposite. So people figured out that if you combine these two, you can get really good readings. So you could do something like an orientation sensor. So what I'm doing here is exactly that. I'm getting the accelerometer values, I'm normalizing, I'm getting the gyro values, I'm getting the time difference, and then I just take a mixture of the two with the weight. My weight here is probably something like 0.89, so I use most of the gyro because I trust it. I just take the difference because it's only sensing angle difference, so take that by time. And then I multiply the rest using the values from the accelerometer. And it seems to work pretty well. But as you can see, it's really, really easy doing these things. So, just to get you all excited, I made a small video. Actually, while working on these generic sensors, I made a small demo app called Compass, which like kind of shows you all these different sensors. But I thought, hey, wouldn't it be cool if we just could use like Bluetooth? I connect to it because I had this like nice Daydream thing from Google. I got a Google I/O. I thought, hey, this is pretty cool. It has a very nice remote. Couldn't I, using Bluetooth, couldn't I just use that for like controlling my sensor? And yes, that was actually possible. So let's take a look. So this is my demo app, and I'm clicking to connect to my Daydream controller. And you see, I can control it using Bluetooth with the exact same API. I just like model the API surface from my controller. It's just like in 1 hour. Super cool. But as I work at Intel, we also work on IoT platforms ourselves. So this is an Arduino 101. This is pretty cool because we have a new Linux Foundations supported real-time operation system called Zephyr. And Zephyr actually has a JavaScript runtime. So this is another project I've been working on. And now there's even a smaller version of the same board. It's really, really small. This is pretty cool. It has Bluetooth, and it has like accelerometer and gyroscope. So I could do the same. So another hour later, I did the exact same. And the cool thing here is that I did it all in JavaScript. So you saw my demo before, like I made this like connecting the device. We're using web USB, it would just like connect and show an IDE. So we actually had a team that went a bit further and said like, hey, let's make this a product. We can do this. We can do it really nicely. So they're working on this like JavaScript IDE for Zephyr. It even shows you how the device looks. So I'm generating a accelerometer, a gyroscope. I'm just sending the value. This is our Bluetooth API. When you get a change event, I'm doing that for both. I'm actually and the value because it's just sending like unsigned integers. I had to do a bit of trick, and because I'm sending like floating point values, so something which has a comma or something in. So I'm multiplying to get rid of that, and I'm doing a small trick to get like negative and positive values. But that will become much easier in the future. So that's basically the code. All in JavaScript. Just hit deploy, and there you go. This is on my client side, so this is my web app. I created a Zephyr controller, and I model the generic sensor APIs. So they basically have like an X, Y, and Z, and they have a timestamp. So every time I connect to the device, I'll set up my characteristic changed. We talked about before. This is here. It will get the values. The values are sent on the other side. It will just put them into either accelerometer data or gyroscope data and call the unchanged event. So this is like all the code I did to make that demo work. It might look a bit much, but it was like quite simple. So now I was mentioning Zephyr. So I'm super excited about doing IoT in JavaScript. It's really, really nice because like it's easy and it's fast. But a lot of these like products you get today which support like JavaScript on IoT devices are based on Linux. And Linux is probably not the best operation system for like edge devices. So when I talk about IoT, I normally talk about like edge devices and regular like gateways. So your sensors in your home are normally very, very basic, and they should be very basic because they're just supposed to measure things. And you don't want to have a lot of security holes there. Then maybe they send all the data to a gateway, which might be much more powerful. It might be something like a Google Home or another kind of device like your router, which will be the gateway. It might run Linux and do all kinds of fancy things, like manipulate the data, try to make sense of it, send it to the cloud. But edge devices should be really simple. And it's kind of scary using like JavaScript, using something like Node.js, where you just like download a lot of modules. You have no idea what they're doing. You don't know if people are making like backdoors in there, and ship that. Because like the first thing in security is that your attack surface should be as minimal as possible. And this is what I think is so super cool about like Zephyr. It's a very small real-time operation system. You can actually read the code and understand what's going on. And you only build in the features that you need. At least it's possible to do that. And with the JavaScript API, things are really easy. So these are some of the things we support today. We don't have the newest ECMAScript 2016-17 features yet, but we do have promises. We have the event system and buffers from Node.js, timers, performance, Bluetooth, all the general things you have on IoT devices like GPIO, pulse width modulations, and we have access to sensors using the exact same APIs. Really, really cool, and something, if you like IoT, I think you should check out. So I think the summary here is that the web is really ready for doing nice experiences. You can do that today. You can also effortlessly connect to different devices using Bluetooth or USB. These things currently only work with Chrome, but I expect as time goes by, more people will implement support for these. Because these are just like super cool features. NFC support, barcode readers and things, it's coming along. It's under standardization, and we'll probably see that within a year or so. We've long missed sensors supported on the web, and that is also happening now. It is currently awaiting to become an origin trial in Chrome. They're already supported using a flag, so you can actually test these things out today. If anyone wants to see, I also have a few demos. So yeah, that's it. The web is ready. Let's build the future. I'm going to share the slides on my Twitter account. So if anyone wants to follow me, I'm Kenneth Rohde. So my first name and my middle name. And yeah, thank you for listening.